Good morning, everyone. It's a privilege and a pleasure to have all of you here. And I am noted for being long-winded, but I'm not going to be long-winded today because there are many people who are greater than I who need to come forward. So therefore, we're going to do that. But before we do that, I just love the layout here. I think they did good. You know, we're not just sitting in chairs. We got tables so we can make it work. And so this morning, we want to give a special person recognition for leading and orchestrating this, Miss Keisha Pierce. You see her sitting on the top back there? While Jay and I sat at home and sweated bullets because we thought this wouldn't work out, Keisha and her team made it all happen, and so we're so thankful. So again, I'd like to follow on with Jay and say welcome. But at this time, we're going to bring one of my first important people, Mayor Tommy Battle. Please come forward.
Cedric, thank you so much, and to all of you, welcome to the Energy Summit. If you're not from Huntsville, welcome to Huntsville. We're glad to have you here. And those who are from Huntsville, everybody raise your hand. It's going to be a good many of you. Okay, those are your hosts here. They're going to buy you lunch, might buy you supper later on. But one of the things that, you know, we have 195,000 people sitting in the city of Huntsville. We have 440,000 people in our SMA area. But one of the things that drives us is technology. And that's why we started this Energy Huntsville 10 years ago. We started Geospatial Huntsville, Geo Huntsville, which was in geospatial field. We have 15,000 people working in geospatial. We started Cyber Huntsville because we knew that that was going to be a growing industry, and we started it 10 years ago. And we started Energy Huntsville because we knew that energy was going to prove out to be long-term one of the most important things that affects our country and affects what we do in the technology fields. We started off working energy, and you know, we quickly realized that there's a couple of ways. There's a sustainable or a way to conservation side on energy, how to conserve energy. But then there's also the production side. What can we do on the production? Can we work with SMRs? Can we work with solar like we're doing at LG Electronics right now? Can we make sure that we produce the new batteries? And we were just talking just a minute ago about batteries and battery technology. Can we produce the new batteries that can take all that energy that's made maybe at night and store it up and then dispense it back out during the day? And the technology base that we have right here, we knew was the technology base that can drive those kind of ideas and those kind of industries in the future. We did it for industry. We did it for jobs. We did it because we have the technical base that can drive that forward. And we want to keep driving those technologies forward year after year after year. You being here helps us with our technology base, helps us to make sure that we continue to move forward in that quest of making sure that we have some of the most efficient energy in the world, and that we also produce some of the cleanest energy in the world, and we keep producing it, and we do it right here from this area, from the technology that comes from this area, from throughout the United States and from throughout the world. So thank you for being here today. Thank you for being part of this. You being part of this is improving the technology of the world, and it's also improving the living and the quality of life of the whole world. So thank you for what you're doing.
Thank you, Mayor Battle. At this time, we'd like to introduce Dr. Deborah Barnhart. Dr. Deborah is the CEO of the U.S. Space and Rocket Center. They just do fantastic stuff. And so we appreciate that. We get people from all around the world, not the United States. And so help me welcome Dr. Deborah Barnhart.
Good morning. Good morning, and welcome to Huntsville. We're so glad to have all of you here in the Rocket City. 50 years ago, a little longer, Dr. Werner von Braun went to the legislature of the state of Alabama, and he said, "We're about to go to the moon from Huntsville, Alabama, and you need a showcase to show the world what's happening here in Alabama." The legislature created the U.S. Space and Rocket Center's commission, and we've been in operation as NASA's official visitor center for 50 years. That statute that the legislature approved, though, called for us to be a NASA showcase, a defense technologies showcase, and an energy exhibition and education center. And some of you were alive in the 70s when gasoline went from 25 cents to 39 cents a gallon, and it was a huge crisis. It was an energy crisis in our country. So we all know that energy is at the nexus of space and defense, and of course our lives here on Earth. So I enjoin you to join us in our mission here in Energy Huntsville to improve the state of the art. Just as we do in Space Camp, we want to inspire you to also change our world and to change our culture and to change technology around energy. And I invite you and your companies to use the Space and Rocket Center as a showcase, just as we were intended to be so many years ago. Philips, is anybody here from Philips this morning? Philips Lighting is going to relight our Saturn V. You may see that we're painting it right now. We're getting ready for the 50th anniversary of Apollo landing this summer. So they're going to relight the Saturn V. I want demonstrable things to show the world that energy is important to us here in Huntsville. It's part of our technology package. It's part of our mayor's initiative for us, and we want to change the world of energy here in Huntsville. So welcome, so good to have you. Please come back the week of July 13th through 20th and celebrate the 50th anniversary of the Apollo lunar landing in Huntsville. Welcome.
Thank you, Dr. Bernhardt. Just before we introduce our speaker, after we finish this speaker session and have breaks, when the break is over, some will come back for the panel and then their breakout sessions. Down the hall, just before you get to the registration tables to the right, when you go down there, each session is on the door. John Trudell said, make sure you look closely because a couple have changed just a little bit. But other than there, you go down the hall, you look on the door, you pick your session, and you go in, and you'll see it there. So if you're headed to the breakout session, just make sure you check and get to the right one. So with no further ado, we would like to now introduce our keynote speaker. And I like a short introduction, and I talked to him, and he likes a short introduction. So we're not going to spend a lot of time. We're going to spend that time listening to what he has to say. So at this time, we'd like to introduce Dr. Robert Ivester. He's a director of the Federal Energy Management Program, better known as FEMP, from the U.S. Department of Energy. He's going to come and he's going to give us an overview of what happened there. So help me welcome Dr. Ivester.
So I have the best job in the Department of Energy. I'm excited to be here today and talk to you about it. And I'd like to just start off and talk a little bit about why I have the best job in the Department of Energy, or at least I think I do. I know Jay probably thinks he has the best job, and we can arm wrestle over it later. So I don't know how familiar y'all are with what the Department of Energy really does. It's not a particularly well understood department. You know, why are we here? What do we actually do? It's a little bit over $30 billion budget, and about half of that is associated with the nation's nuclear weapons stockpile. So there's your first piece that most people don't realize, but some do, is you know, we take care of the nukes. So that's about half the budget. And then out of the remaining $15 billion, about a third of that is cleaning up the mess that we created when we started the nuclear weapons stockpile, which we call environmental management, or EM. So that's another $5 billion. And you know, setting aside policy issues and personal opinions on whether or not we should have nuclear weapons, just as a federal employee, I would sum up the job of both NNSA and which is responsible for the nuclear weapons stockpile, and EM, is avoiding something really bad happening. So they spend the entirety of their career trying to prevent bad things from happening, and so I don't personally find that rewarding. I don't really want to do that as my job. And then out of the remaining $10 billion, about half of that, or $5 billion, is for the Office of Science. Do I have any scientists in the house? Okay, a handful. So I'm an engineer, and I used to work at a national lab with a bunch of scientists. And so I apologize, not all scientists feel this way, but some do, which is essentially if, as a scientist, your work has an impact on the world around you while you're still alive, then you're not pursuing a fundamental enough path. That you're supposed to change the world for the people that come after you, not the world that you're actually in. That's what the engineers do, and I'm an engineer, and so that was said with a sneer towards engineers, and was intended like we're above you because we impact the world after we leave it, and so that also does not really appeal to me. I don't want to work on something that's going to change the world after I'm not in it. I want to see the results of my work changing the world that we're in. And so there were a handful of scientists, and I'll lump you all in with the rest of us as people who want to change the world that we're in. And so the remaining $5 billion is what we call applied research. And so that is operating in a mission space around energy concerns where we're trying to make change in the world that we live in. And so we get wonderful opportunities to see all sorts of things that have happened, and then we can trace back and go, you know, when that product entered the market, that's a direct consequence of something that the Department of Energy funded or did 3 years ago or 5 years ago. And so as we're working on things, as we're driving new technological developments, we get the opportunity to see those developments propagate out into industry and have an impact on the world around us. So what better position to be in? And so I'm going to mostly talk about the Office of Energy Efficiency and Renewable Energy. And that's about half of the applied research portfolio. It's a little bit over $2 billion. And it's just a fantastic mission space where we're taking fundamental innovations that have been driven by scientists and translating those into technologies that impact people's everyday lives. So as a quick example, there's been a lot of work in the world of science around photoelectric effects and photochemical effects, and that basically is what led to our ability to have solar cells. So the Department of Energy Research fine-tuned how does a solar cell work, and now we have PV arrays all around the country helping provide energy. And what EERE's contribution into that was really targeting cost reduction. And now we have PV arrays that are directly cost competitive with non-renewable sources of energy. And that's a fantastic place to be. And that was something that the Solar Energy Technologies Office really set out as a goal, and said we have a 10-year goal to get solar directly cost competitive with no subsidies. And it varies a bit from place to place as to how powerful the PV arrays produce. I was stunned about, let's see, 8 months ago. I went out and went to a state and saw massive deployments of solar. And it was in a place that I didn't think really was a great place for solar. But it turns out it's a fantastic place for solar. And I'm playing it out a little bit, but that state was Alaska. You know, there's parts of Alaska that don't see the sun for months, and they're putting solar there. You know, how does that work? You know, well, one is the cost of energy in Alaska is high, relatively speaking, and two, there are months also where the sun doesn't go away. And then second, and this was something that was interesting to me, and I fed back to some of my colleagues in the solar office, is that there's an engineer parameter for solar energy performance, and it varies from 0 to 1. where one is essentially you're making perfect use of the direct sunlight and converting it all into electricity. So it's a nice little, engineering parameter of what's your, how effectively or efficiently are you operating. And at times in Alaska, they exceed 1. You go, well, how does that work? How do you beat 100% efficiency? And the answer is that they get indirect sunlight because it's white everywhere most of the time because of all the sunshine, all the snow, and there's so much of it, and there's so much reflected light. It's so powerfully reflected that under the right performance conditions, they perform higher than 1. So it's not higher than 100% efficiency in the sense that they're not like magically producing energy out of nothing. It's just that the engineers defined it as direct sunlight and they neglected all the indirect stuff. So I have a clicker. Could I go to the next slide, please? All right, so I've got a fair amount of slide content that I'm going to gloss over or at times ignore to try and keep on pace. We're happy to make my slides available. I'll wave generically because someone at the back table probably is going to say, yeah, I'll take care of that. Anybody who wants Rob's slides can have them. So we've got some really impactful things that have happened. I'll start at the bottom. Light bulbs have gone from, incandescent was everywhere, and then we went through this sort of iffy phase, I'll say, with the compact fluorescents. I still have some in my house. I still have some new ones in the box that I haven't installed. And now I'm not quite sure what to do with because I hate compact fluorescent light bulbs. But I don't want to throw them out, and I paid perfectly good money for them. And now basically everything's LED, and the cost of LED, similar to solar cells, it just doesn't make sense to buy incandescent bulbs anymore. Unless you have free electricity, why are you throwing that money away? So operational costs of an incandescent bulb are about $8 a year, and an LED bulb is about $2 a year. So you save 75% on your electric bill by buying that LED bulb. And so the payback time, the LED bulbs are now, it depends if you want special lights or a little bit more, but just a regular light bulb is, $1 or $2. What's really a differentiator in the light bulb market now is increasingly is light quality. Is that people are instead of really focusing on, I want a light bulb that uses this much energy, like most of the market is bought off on that, and they understand the idea that LED bulbs are less expensive to operate. But they're going and saying, you know what, instead of paying $2 for a bulb, I'll pay $3 for a bulb, and I'll get that nicer name brand one that's going to have a higher light quality. And it's having significant impact on our daily lives because we're more able to afford high quality light in the places that we need it. And then, the chart on the upper left is just plotting out the output of solar cells, and we really see a significant jump coming. And that's the red dot up above, and this is a great example of the kinds of things that EERE does, is that we support activities in a laboratory environment, but we don't just do it in a sense like 12 PhDs babysitting a petri dish, where they've achieved some magical new reaction, but it's not practical for the real world. It's laboratory environments where they're testing under real world conditions, and we're seeing solar cell output is preparing for a big jump. So it's directly cost competitive today, but we're going to get a factor of 2 or 3 improvement in the output of solar cells. And increasingly, we're going to see, like with LED light bulbs, there's going to be, well, why haven't you put solar arrays on your roof? Like, what's holding you back? Because it's going to pay for itself in 6 months. It's not this like 10-year time frame where it has to be carefully planned out and invested. It's more just something, you just put it up there and you're going to get your money back in a period of months. And that, to me, is part of why I think I have the best job in the federal government, is that I get to be in the middle of all this and seeing the outputs of the technology offices and have them impact the energy consumption of the federal sector and help federal sites and facilities adopt these latest technologies, improve their efficiencies, improve their energy productivities, and contribute to making the world a better place. Thank you. Yes. No, perfect. It's like you're reading my mind. So we're organized in EERE. I like things in threes. I don't really know why, but it seems to work for me. We're organized in the chart on the right into 3 different sectors that are approximately equal in size. It's convenient that things kind of work out in round numbers. But the total United States annual energy consumption is about 100 quadrillion BTUs or quads. And then if we divide the sectors up into transportation, renewable power, and energy efficiency, they're each in the 30s for quads of size. And so I'm going to talk a little bit about each one of these. And then on the left-hand side, from a mission standpoint, we fulfill 3 different roles. I've talked about our role in research, and then I've talked a little bit about the second one, which is really that we're validating the technology works. We're demonstrating to investors in those technologies that this is a technology that's worthy of their investment. And then third is that we're also watching carefully for market issues and things like, is the workforce ready to and in place for those technologies to be realized? And a critical point that I want to make on this is that we don't do these 3 things sequentially in the way that you might think of it, like, well, first we'll do some research on some type of a new solar cell and see if we can improve output, and then we'll test it and see how well it works, and then we'll train people. If anything, we do it the other way around. We have to look to the marketplace and say, what are the barriers that are there that are going to get in our way, and let's make sure we're cognizant of that before we do any science. And what are the concerns that investors are going to face? And let's be cognizant of that before we put any of our investment in. And so we're looking to the third and the second part and thinking about them very carefully as we execute on the first part. And that really improves the likelihood that the investments in research that we put in are going to work, because we're looking at areas that are likely to be fruitful from a technology performance standpoint. It's going to work in the real world. And it's likely to be fruitful in the sense that the market's going to take it up. If there are barriers there that we can't overcome, we have no business investing in precious taxpayer resources in the research in the first place. So we have to make sure that everything's in alignment. All right, next slide, please. So I know this is a little bit hard to read. The 2 charts on the left are showing energy productivity and personal energy expenditures. And these are all over the time period of the year 2000 and 2016. And what we see is that overall energy expenditures as a percentage of total expenses has dropped significantly, which is great for us. It's great for our economy. We're spending less money on energy at the personal level. The one on top, though, I want to make sure that that I emphasize, because we use the term energy efficiency, and I actually really prefer the term energy productivity, because energy efficiency leaves the door open to just not turning the lights on, not heating the air, not running the air conditioning, not driving your car. I can just shut down as a human being and sit in a room and not do anything and consume no energy. But I won't contribute value into the economy. I won't enjoy my life, and eventually I'll starve to death. So we have to really think about energy in the context of what do we do with our lives. And so that's why I like productivity, because this is gross domestic product, or GDP, divided by energy consumed. And that, I think, just starting right there and saying, let's work on energy productivity. Let's not cut our energy use in half. Let's double our energy productivity. Let's make twice as much value for the same amount of energy. Or maybe we make the same amount of value and use half the amount of energy. But let's use that energy productivity really as our focus and as our target, because it puts the emphasis on the value. It puts the emphasis on, why are we here as human beings? We're trying to contribute value into society. Let's not let energy efficiency be the driver of holding us down and not generating value, not living. Let's put the emphasis on that value that we create. Then on the bottom, in the middle, on the bottom, on the right, are our emissions levels. And over that same time period, NOx and SOx emissions have fallen by 2/3. So we have much cleaner air. And then at the same time, our carbon dioxide emissions have dropped by 13%. And then if you look, the dashed line, it's a little bit hard to read the smaller text, but the power sector alone has dropped its emissions by 22% over that same time period. We have not dropped our energy generation by 22%. Let's just be clear on that. Energy generation has gone up, but at the same time, our carbon dioxide emissions have gone down. And then we see 63% growth in renewable electricity. So we've had just a massive growth in 16 years in how much of our electricity is renewable. And then in the middle on the top, we've seen significant, but we still have a lot of room to work on. So that's the VMT is vehicle miles traveled. So we're traveling 17% further per overall as a sector in transportation, further per barrel of oil. So we're doing pretty well, but that number needs to come up a whole lot more, and I'll talk through some of that as I get into the rest of my talk. So I've talked about the second and the fourth row a fair amount. We've seen in the cost reductions column across the board really dramatic decreases in cost. I mean, a 94% decrease in cost for LEDs is just amazing. There's room to do that in the other three. We're only part of the way there. There's no reason that wind and solar and batteries shouldn't be, in a sense, functionally free. Like they pay for themselves in a very short period of time. And we've seen pretty significant growth. So one of the real success stories is the first one in land-based wind. We're now generating 82 gigawatts as a country through wind. That's a pretty big number, and a little over. And this is the change is over a decade. So 10 years prior to that, we're only at 11 gigawatts. So we've seen massive adoption of wind. And if you fly around the country and open up the window and look down, depending on what part of the country you're over, you'll see it. You'll be like, oh my goodness, look at all those wind turbines down there. And that's a fantastic thing, because those are basically paying for themselves. And the growth in the wind industry has also created a lot of jobs. And we've seen similar massive adoption in the solar industry and correspondingly a significant number of jobs. And if you add up all those numbers, unfortunately we're a little bit shy of the million mark. But you know, we've got well in excess of 800,000 jobs in the renewable sector just from these 4 technologies. And then the one that I haven't really talked about is the EV batteries and electric vehicles. Just a quick show of hands, who knows somebody who drives a hybrid? Yeah. Who knew somebody who drove a hybrid more than 10 years ago? Yeah. Hybrids are now basically everywhere. And it's also more or less true that we now have a nationwide network of available chargers. A decade ago, we didn't have that. Assume everyone here knows that those batteries are based on lithium ion in those cars. Who here knows about the role of cobalt in electric vehicles? Yeah, not so much. If we stay on the trajectory that we're on, we'll consume the world's supply of cobalt in under a decade. So we have like a big roadblock. Remember I talked about the market barriers? We got a problem ahead of us. We can't make nearly enough vehicle batteries for everyone to have an electric car because there isn't enough cobalt in the world to do that. And there's political sensitivities that I'll just kind of gloss over, but I'll just say the world's supply of cobalt is at times morally problematic. And so we've been working hard in EERE at eliminating the role of cobalt. Unfortunately, cobalt that's a tough nut to crack because it does really good things in batteries. It helps batteries be really good. You know, we need the lithium, and people have talked about lithium supply. That's only part of the problem. The cobalt supply is actually a bigger problem, but we now see a pathway to eliminate all cobalt and lithium-ion batteries in under a decade, which is good because we're going to run out of cobalt in under a decade. So we're maybe not moving quite as fast as we should, but we have a path forward on that. Okay, so this is probably my favorite slide. I'm coming up close on the end of my time slot. So this is probably the takeaway message that I want you guys to all absorb, and I'm just going to ask you collectively to go proselytize the great word. And the great word is the cheapest energy to save, the cheapest form of renewable energy is the energy that you don't use. So what you're seeing here is the green bar is the range of the costs for energy conservation measures. And the gray bars are all the different ways that you can create energy. And so you can see there's only partial overlap that under the best of conditions, wind can be slightly cheaper than energy conservation measures under the worst of conditions. Other than that, you're far better off conserving energy than generating more energy. And it's actually much easier, and it pays for itself in a much shorter period of time. And in essence, that's why we're all here, is to talk about energy management and energy savings. And those energy conservation measures renew themselves and pay for themselves in a far faster time period than generating new energy. Okay, so I've got about 6 slides here that are kind of eye charts. And I'm just going to talk to them at a very high level and quickly and then wrap up my talk. So this slide is on the energy efficiency sector. So remember I showed the circle with the 3 different pieces. This is approximately 1/3 of our energy consumption, and it's approximately 1/3 of the energy efficiency and renewable energy office. We're organized into 4 technology offices. Those are shown on the right. The Federal Energy Management Program that I'm the director of is the 3rd one. And we've got some nice little pictures here. I haven't talked about the Advanced Manufacturing Office, which is where I came from. So I'm just going to put in a short plug on this slide for the picture there sort of in the middle. So for those of you that don't recognize that, that's a Shelby Cobra in original blue with the white stripe on double stripe on the hood. What you probably don't know, but maybe some of you, has anybody heard about this car? Anybody know this story before I tell it? Okay, a handful of you. Okay. In 6 weeks, a team at Oak Ridge National Lab met a challenge, and we in the Advanced Manufacturing Office kind of threw down the gauntlet and said, yeah, you guys talk pretty big. Let's see if you can actually deliver. I want you to 3D print an all-electric Shelby Cobra in 6 weeks. And they did it. Now, it wasn't, to be fair to them, it really took them 12 weeks. But in 6 weeks, they went from a few people sitting around in a establishment that serves alcoholic beverages after hours and a cocktail napkin. And that was the start of the 6 weeks, is, okay, we can do this, let's plan it out. And 6 weeks later, they had a fully drivable operational car. To be fair to them, it took another 6 weeks to make it look pretty, but in 6 weeks, it was operational. And that, I think, is a great example of the kind of transformational, disruptive technologies that are really going to change the energy landscape. And I go back to energy productivity quickly for a moment. The manufacturing sector accounts for almost 1/3 of our national energy consumption, is between 1/4 and 1/3. Manufacturing is absolutely vital to our economy. It's vital to our national security. We cannot afford to lose our manufacturing capability. When we talk about energy efficiency, we don't want to drive manufacturers out of business by telling them that they can't use energy. And I know that it's very important to Huntsville, it's important to Alabama, it's important to the Southeast. Manufacturing is the bedrock of the economy in a lot of the country. And new technologies give us the opportunity to improve our competitiveness on the global stage. So all those charts, like the adoption of renewable energy, being up by 66%, we also want to see numbers like that in advanced manufacturing. We should be the world's centerpiece of advanced manufacturing technologies, and we should be doing that in a way that's highly energy productive. And then we should figure out as a society, how do we manage to meet that energy need while we're meeting that economic need. This is a collection of impacts. I've already talked about the LED research. I'll just pick out quickly in the second line there, high performance computing R&D. We cheated. We did, in the Advanced Manufacturing Office. It was an exciting initiative that we launched around high performance computing, and I'd say we cheated because NNSA and the Office of Science have paid enormous sums of money to create some of the world's best supercomputers at our national labs. And we, EERE, didn't pay for any of that. However, we, EERE, get to go buy time on those machines. And so that's how we cheated. So, I mean, we paid for the time, but we didn't pay to create the whole system. And what we did is we said, there's a lot of interesting applied problems out there that could really benefit from the use of high-performance computing. And these computers have just absolutely mind-boggling, astoundingly powerful computing capabilities. And I forget what the, I forget what the word is. No, but it's the peta, that's it. No, it's petaflop. Thank you. We're not at EXA yet, but I was at the launch of one of the high-performance computers, and the CEO from NVIDIA that contributed together with IBM the new processors put it in great perspective. So peta is a 1 with a whole lot of zeros after it. I forget how many, and it kind of doesn't matter. It's a lot of them. You look at it, you go, geez, that's a lot of zeros. And I think it's 22, but whatever, it doesn't really matter. What really put it into perspective is the age of the universe is estimated to be half of a petasecond. And the new machine can do, I think it's 200 petaflops. So all those zeros, floating point operations per second. So that, you know, age of the universe times like a couple of hundred in seconds. It can do that many operations in 1 second. So it's a lot of operations. And you go, you know, we've got some cool problems in the energy sector, and we could throw some interesting computer horsepower at solving some of those problems, and that's what that high-performance computing R&D program is there for. So if you know anybody that's in the manufacturing business and is an energy consumer, that's still an active program. There's a call every 6 months, and companies can go tap into that computer horsepower. And there's some great success stories that have come out of that, including a steel plant that saved 10% on its annual energy consumption because of the modeling that it did of the steel foundry operations. Second sector is transportation. So we have the vehicle office, the bioenergy office, and the hydrogen and fuel cells office. And I said I like things in 3, so we have 3 offices and 3 thrusts. There's a lot of work. Most people are thinking, when they think energy and vehicles, they think about vehicle efficiency. So I'm actually just going to completely skip that one and say fuel diversification is actually equally important, and there's a lot of efforts going into using different types of fuel. And so, you know, we've all heard about, you know, used French fry grease and, you know, running your old VW bus off of that, and it kind of, you drive around and you smell like French fries. You know, that's cute, but we need a whole lot of French fry grease, and we'd all die from heart attacks if we ate that many French fries. So we got to do something other than that. We can't use used fry oil. But fuels that we can directly drop in so that we don't have to change the existing vehicle fleet. So things like E85 that we can pump into existing cars. And then there's a lot of opportunity in the fuel cell space and in the world of hydrogen. We've had tremendous advancements in that in safety and technology capability, codes and standards to certify that the systems are safe. We've seen significant fleet adoption. The big challenge we have with hydrogen at this point is really supply deployment. We don't have the hydrogen, the equivalent of gas stations everywhere supplying hydrogen. And then the second one is cost-effective and renewable creation of hydrogen. So we can make hydrogen, it just costs more than pumping oil out of the ground and making gasoline. And then the third area, mobility systems, that I just want to talk about a little bit is the world is increasingly interconnected, and vehicles have a crucial role in that. They're the mobile connection point for almost all of us now. I mean, I know I drive an older car, but I travel a lot for work, and when I rent a car, I get a car with a much fancier IT system than the one that I drive. Increasingly, cars today have very sophisticated computers in them that can do all sorts of things. They all want to talk to my phone, and then when they talk to my phone, they can do all sorts of magical things for me. But it goes well beyond anything that what we're doing today with our vehicles and our phones. The interconnectedness of things is really providing tremendous opportunities. The one that I think we all know is you use Google Maps, and it's getting all those traffic updates. It's deriving all of that off of our phones that are in our pockets. It knows how fast the cars are moving because it knows how fast the phones are moving. And it's something that was a development that just sort of magically happened. Like, there was this thing called Maps, and it would navigate you places, and then all of a sudden it had these color-coded status. They basically did a small software update and took advantage of information that was there for free. There's a world of developments like that in vehicle space, where there's all sorts of innovations that are coming because of the connectedness of our vehicles. And so it's an important area for ERE to have a research thrust in. Stay tuned, more cool stuff is coming in your car. And we've had the impacts for the transportation sector. There's a lot of cool things on here, but the one that I'll just call out is the third one, which is on biofuels, is that the fuel costs have been cut by 80%, and the durability of the fuels has quadrupled at the same time. So biofuels aren't quite here yet in terms of being on the market, predominant. We're not off of petroleum, but that day is coming. It's less than 10 years away. And it won't be a change that you'll make. It's like with LED bulbs. It's a change that the market will make around you. And you go, well, of course I do that. It's cheaper. It's not about ecological desires or tree hugging. It's about productivity. Why would I use petroleum? It's more expensive. And that is the true driver of change in the broader society. So renewable power, I've talked about solar and wind. I haven't talked about water or geothermal. We've had hydropower in this country for a long time. One of the things that that's exciting in the world of water right now is the hydro provides, as you guys all know, a renewable source of electricity. Something that you guys might not know is there's a relatively new term being thrown around called pumped hydro. And what pumped hydro really means is when electricity demand is low, we can stop generating by flowing water through a dam, and instead we can pump water and raise the water level behind the dam. And then when electricity is needed, we can then flow that water back out. And so in a sense, many of our hydro facilities can now be thought of as massive batteries, because when electricity is cheap, we buy electricity and pump water, and then when it's expensive, we produce electricity. And so our hydro systems are having a really critical role in the ecosystem because they can store on a massive, massive level. And then the other one is geothermal, which has really come a long way in the last 10 years and is going to come even further in the next 10 years. One of the things that's really exciting about geothermal is we don't know the answer. And we have all these surveys of what's underneath the surface for oil and gas. So we don't have perfect knowledge, but we've got pretty good knowledge of oil and gas reserves and where they are in the country. We know next to nothing about our geothermal opportunities. We haven't mapped the country yet. We don't know where it is. If you've ever been to Iceland, they make massive use of geothermal there. They're a great geothermal resource. They're 100% renewably sourced. Geothermal is endlessly renewable. You use a little bit of electricity to pump something down into the ground. It gets nice and hot, and you pump it back up, and then you use the fact that it's hot to generate energy. So you need to drill a hole in the ground. It needs to be pretty deep, and it needs to be hot where you drill the hole. We don't know where it's hot in this country. We don't have a good understanding of where our geothermal resources are. Could be that we have terrible geothermal resources. It could be that we have amazing geothermal resources. The reality is we have some. We know it's not terrible. We know where some of it is. But there are huge swaths of the country that we literally have no idea whether it's any good for geothermal or not. And we'll find out. In the meantime, bringing the cost of deployment down, bringing the efficiency of the technology up is something that we're hard at work on, and we've made significant progress on, and we'll continue making great progress. We are going to have, 20 years from now, a lot more geothermal deployed than we do now. And like water, geothermal and water on the bottom are much more stable sources. So one of the things that everyone hears about solar and wind is they're great when the sun is shining, they're great when the wind is blowing, but then you get a dead spot and you don't get any wind, then you don't have any energy, and then you got to go back and turn on your gas plant and generate some energy. Well, geothermal and water can provide steady, continuous energy under any conditions. They don't really need, I mean, water, it needs to rain once in a while. If we have a true drought, it's going to impact our ability to generate water. But because we have pumped hydro, we have the ability to really generate water over a long period of time, generate energy over a long period of time. So I'm going to skip over the success stories on the renewable power because I'm out of time. And we see great opportunities ahead across all three sectors. EERE is a really exciting place to work. Being the FEMP director gives me the opportunity to essentially be the concierge to the federal energy consumers and help them adopt the technologies as they come out of the other parts of EERE. And we just have a whole barrel of fun ahead of us for the next decade, and I look forward to every day. So thank you all very much.
Thank you, Dr. Ivester. And we're ready for a break. We're going to squeeze you a little bit because we ran behind. He had a lot of great things to say. So let's go outside, but don't forget to go to the breakout sessions. It's on, I did have it up, page number 9. Look on page number 9. If you're going to the breakout at the appropriate time, we'll bring you back. Thank you very much.